Welcome students, my name is Shampa. Today we will understand how to find the lateral surface area and the total surface area of a cone. So let's begin. Now this is what we call a cone. Let's draw it on the paper so that we can understand some of the important parameters related to the cone. Now this is the diagram, the inside part of this cone. See, this is the height. Now this is the height of this cone, and we see the base of the cone is circular, and this is the center of the circle, and now this is the radius of this circle. This circle, we see the base of the cone is circular, so this part is circular. So this circular part has a radius, let's call it R, and this cone, it's a three-dimensional figure, so this has a height, let's call it H. In terms of cone, we call this hypotenuse as the slant height. We will come to know this is very important parameter. We will use it to find out the lateral surface area. So we can see that if this is the height, this R will form the base and this will become a right angle triangle. And this height will become the height of the right angle triangle, and this R will become the base of the right angle triangle. In that case, we can find out the slant height using the Pythagoras theorem. What does the Pythagoras theorem say? It says h square plus r square is equal to, let's call the slant height as L. H square plus R square is equal to L square. So we can find out L using the formula. L is equal to square root of H square plus R square. So if we know the height of the cone and if we know the radius, we can find out the slant height of the cone. So that was easy. Now let's move on to our quest to find the lateral surface area. Now lateral surface area means the amount of material required to construct this cone. Not this part, not this hollow part, this part, the amount of material that is required to construct the body. We will consider this part if this was covered with a circle and this cone was a covered cone. We will come to that later. That will be considered under the heading of total surface area. But right now our focus is on lateral surface area. So we need to find out the lateral surface area to know the amount of material, the area of the material that has been used to construct this cone. So let's begin. Now if we open this cone, if we remove the stapler and we open this cone, it would resemble something like this. Now as we know, this cone has a circular base and this circular base has a radius. So this circular base has a circumference of 2 pi r. Now that it's been expanded, so we know this entire circumference is 2 pi r. See, this is the cone we have, and if we open it, this is 2 pi r. If we open it like this entire circumference is 2 pi r, and this is the slant height, that is this height. Let's refer to the last figure. Here we have this hypotenuse as the slant height. Here is the slant height. If we open it, It will be this parameter L. So this is the slant height. We will call it L. Say, now let's do one thing. Let's divide this entire circle into some right angle triangles like this. And the right angle triangles will have the height as L and the base, let's say it is B1. This is B2. Let's assume they are very small triangles. And if they are very small triangles, the base will almost become flat. So let's consider this as B1, this as B2, and then this as B3, and so on. So we will divide this entire circle into very small right angle triangles. So in order to find out the lateral surface area of this cone, we will add up these small right angle triangles. So how are we going to do it? The sum of all the right angle triangles is going to be like this. This is going to be half into, let's consider this first triangle. So we know the area of the triangle, half into base into height. So here we have the base as B1. See, this is the arc of this big circle, but because we have assumed these are very small triangles, so in that case this base will become almost flat. So we have actually considered that this is very flat. These are very small. For the sake of explaining it, I have made it a bit bigger. But when these are very small triangles, this circumference is almost flat. This part of the arc is almost flat. So let's consider it half B1 into, what is the height right now? This L, the slant height is the height, half B1 into L. For now we will consider the second triangle. We have half into B2 into L, and this will go on till it is, this will go on till it is half into Bn into L, where n is the number of triangles, n is the last triangle we have made. So we have added all the triangles. Let's assume we have divided it into many small triangles, and now that we have added all the triangles, the result will be, we can take out L by 2 as common, and the result will be B1 plus B2 plus B3. Let's assume this was B3, so on till Bn. So here we have taken out L by 2 as common, and we will add all these bases, B1 plus B2 plus B3 till Bn. But we should not forget that this entire part is the circumference. This is nothing but 2 pi r. So instead of B1 plus B2 plus B3 till Bn, we can write L by 2 into 2 pi r. So this 2 and this 2 will get cancelled, and we have pi r L. This is the lateral surface area of this cone. So that was easy. So we see that if we know the radius and if we know the slant height, we can find out the lateral surface area of a cone. So that was easy. And if we don't know the slant height, we can find out the slant height using the Pythagoras theorem, that is h square plus r square is equal to L square, where L is equal to, so we have L equal to square root of h square plus r square, where h is the height of this cone and r is the radius of this circular part. Now let's assume that this cone has a cover now. In that case, we will have to find out the material that will be required to construct this lateral surface area part and this cover part. We know this cover has a radius r, and this radius is same as the radius of circle, this circular base. So we know we can find out the area of this cover. The area of the cover, we know the area of the circle is this area. This is nothing but pi r square. So if we add this area, the area of this circle with the lateral surface area, we can find out the total surface area. So here we know the area of the cover is equal to pi r square, and the lateral surface area of the cone we know is pi r l. So we can take out pi r as common, and inside we will be left with r plus l. So this will comprise the total surface area of a cone, that is pi r into r plus l. So that was pretty easy.